You ever wonder how your phone just knows your face, or how your email is so good at spotting junk mail? Well, that's machine learning in action. And you know what? It's not magic. It's a process. So let's break down exactly how a machine actually learns. I mean, really think about it. Your email client filters out spam almost perfectly. Your favorite streaming service seems to know exactly what you want to binge watch next. How does it do that? It all boils down to this one simple question. How does a machine really learn?
So here's the secret. There's no single magical trick. Machine learning is actually more like a toolkit. It's got a bunch of different teaching methods for different kinds of problems. Today, we're going to explore the four most important tools in that kit.
Okay, first up is the one you'll run into most often, and it's probably the most intuitive. It's called supervised learning. And honestly, the best way to think about it is like a student who has a really dedicated teacher.
The key here, the absolute secret sauce, is the data. We feed the algorithm a massive data set where the answers are already included. We're literally supervising its education. So think of it like this. We show it thousands and thousands of pictures, and each one is already labeled cat or not a cat. The algorithm's only job? To work backward and figure out the visual rules that define what a cat is.
The process itself is actually pretty straightforward. First, you feed it all that labeled data. Then, the algorithm just churns through it, finding all the little patterns that connect the data to its label. And once it's trained up, you can show it a brand new picture it's never seen before, and it'll predict with pretty amazing confidence whether it's a cat or not.
And this right here, this is probably the most important distinction in all of machine learning. On the left, you've got data with the answers included. That's labeled data. On the right, it's just raw data, no tags, no hints. Understanding this difference is absolutely key for our next method.
So this brings us to method number 2, unsupervised learning. Now, if supervised learning is a student with a teacher, this is way more like a detective showing up to a crime scene. The only instruction is, figure out what happened here. Find the hidden clues.
With this one, we give the algorithm a huge pile of that unlabeled data we just talked about. No answers, no hints, nothing. Its job is to find the hidden structures all by itself. For a business, this could mean something like automatically clustering customers into new marketing groups they'd never thought of, or discovering weird relationships in sales data that no human would ever spot.
And the practical uses for this are just huge. I mean, this method is so powerful for finding hidden market trends or grouping similar things together. But one of its real superpowers is detecting anomalies, the outliers that just don't fit the pattern. And that makes it perfect for stuff like fraud detection, where you're basically looking for that one strange transaction that stands out from the rest.
So, we have learning with the teacher and learning completely on your own. But what if there's a middle ground? Of course there is. That brings us to our third type, semi-supervised learning.
Now, this is where machine learning gets really, really practical. Why? Well, because manually labeling data is incredibly expensive and it takes forever. The genius of this approach is that you can use a small, affordable amount of labeled data to unlock the potential of a massive, basically free amount of unlabeled data. It's the best of both worlds.
A perfect example of this is probably sitting right in your pocket. You tag your friend, let's say Jane, in just a few photos on your phone. That's your small, labeled dataset. The algorithm then takes what it learned about Jane's face and scans thousands of your other unlabeled photos to find her in those too. So, a tiny bit of human help goes a very, very long way.
Okay, so our first 3 methods were all about learning from data that's already sitting there. But our fourth and final method, it's completely different. It's not about studying existing data, it's all about learning from action and consequence. This is reinforcement learning.
So here's how it works. We create a software agent and we drop it into some kind of environment, like a video game. This agent has a goal, and every single time it makes a move that gets it closer to that goal, it gets a reward, like a point. Every bad move, it gets a penalty. It learns simply by trying to get the highest score possible. This creates this really powerful feedback loop. The agent takes an action, it sees the result, it gets a reward or a penalty, and then it updates its strategy, which is called its policy, to try and get more rewards next time. You let it do this over and over, maybe millions of times, and it can develop incredibly sophisticated strategies that no human would ever think of. And this isn't just for playing games, not at all. Reinforcement learning is the brain behind modern robotics. It's what optimizes these super complex factory floors and what schedules massive supply chains. In pretty much any complex system, this is the tool you use to find the absolute best strategy to maximize some kind of reward. So there you have it, 4 really different ways of teaching a machine, but at the end of the day, they all share the same ultimate goal: to turn raw data into knowledge and then into action.
Let's do a super quick recap, okay? Supervised learning predicts outcomes using data that already has all the answers. Unsupervised finds hidden patterns in data with no answers. Semi-supervised uses just a little bit of labeled data to make sense of a whole lot of unlabeled data. And finally, reinforcement learning figures out the best strategy through pure trial and error, rewards, and penalties.
Each one of these methods is incredibly powerful. But this leaves us with a really fascinating final question to chew on. As AI gets more and more woven into our lives, which type of learning is going to matter most? The predictor, the discoverer, the one that leverages what it has, or the strategist? Definitely something to think about. Thanks for joining me for this explainer.